Okay, so now that we've got our pilot hole drilled, we're ready to move on, and we're going to go ahead and rough and finish the ID profile of this part. So you know what we're talking about there is basically we've got to rough all of this material out, and then we want to finish this wall to get everything on size. So that's the next two toolpaths we're going to work through. We'll do those both in this video, so just follow along and pay attention to all the steps, and here we go. All right, so even when we're working on ID, we're still roughing. So the first thing we're going to do is we're going to pick a roughing toolpath. So I'm going to pick rough, and then I got to pick the partial profile for what we're going to work on. So I'm going to pick the start of this chamfer here, and I'm going to pick it kind of up towards this end so it's going into the part here. Make sure your arrows are going the right direction there. If they're going up like that, you need to flip them before you select your last entity, which is going to be the last line right here. Okay, so there we go. There is our profile we need to select. All right. For the tool, we drilled a 3/4 inch pilot hole, so let's go get a 1/2 inch bore bar. So there's a 1/2 inch right there, 0.5 diameter boring bar. So I'm going to select that. Okay. Typically, when you're boring, everything's going to be a lot slower than what it will be for your turning. Obviously, the boring bar is not going to be near as rigid. I think we've all experienced that out of the manual shop. Same thing applies in the CNC lab. So we want to make sure that we're slowing things down a little bit. My feed right here for roughing might be like 6 thou per rev. My CSS, if I'm running 600 constant surface speed turning, I'm probably running about 300 when it comes to the boring tool. And even less, the smaller that boring tool is, the slower I'm able to run it. Otherwise, we're going to get a lot of chatter, and we're not going to get a very nice finish. My max spindle speed, I'm going to drop that all the way down to like 1,000. And I'm going to turn on my coolant. I'm going to give it a comment here. We're going to rough inner profile of bore. Okay. And then we can go ahead and go over to the next page for the rough parameters. We want to make sure overlap's turned on. Okay, typically I don't ever shut that off. I always leave that on. For the entry amount, it's going to start 100 thou off the front of the part. So I'm good with that. Equal depth of cuts, and I'm going to tell it my max depth of cut here is about 50 thou. Okay. Then on the minimum depth of cut, I'm going to tell it, I want that to be at least 5 thou. Or actually, let's make it a little more than that even. Let's say minimum depth 15 thou. Okay. Stock to leave, we're going to leave 10 thou on both of the walls for the finish pass. I'm okay with that. Okay. And then down here, I'm going to turn on stock recognition, and I'm going to tell it remaining stock. I usually go with remaining stock. So if you're looking at your book, it tells you to use the stock for outer boundary. I usually just go with the remaining stock. That way it actually looks at what we've already got rid of out here. Okay. One-way cutting method. Angle, we're coming in from 0 degrees. I'm okay with that. Cutter comp to the left. Since we're on the inside of the part, we got a comp left. We comp right when we're on the outside of the part. So that's good. Lead in, lead out. Okay. We're going to go ahead and for the lead in, I'm going to come down at the angle. So because we're starting with this angle here. So I'm going to change my vector to come in with that chamfer up there. And then on the lead out, I want to extend through the back of the part, and I'm going to tell it to extend through it an extra 50 thou. Okay, that way we get through the end of the part there. That's basically just going to get it broke through the hole there. Okay, so that's pretty much it. It's a lot just like the turning toolpath. When we check mark out of this, there you see what the roughing toolpaths are going to do here. You see it's going 50 thou past the end of the part, so that's good. And there's what our roughing is going to look like. So we're good with that. Okay. All right, now we're going to basically do the same thing because we're going to finish this out. So let's go ahead and let's do a finish toolpath. I'm going to pick the last geometry here, so it grabs that same chain. I'm going to set up my CSS for this. I'd probably slow it down a little more, probably even less on my spindle speed. I might say, hey, I'm going to slow you down 250 more, and my feed per rev is going to be like 2.5 thou. I turn on my coolant, and I'm going to say finish inner profile of contour, or whatever you want to call it there. Okay, so that looks good for my toolpath parameters. Let's go to my finish parameters. On this ID, it does have the radiuses in there. Typically, if there's a radius, I usually want to change my cutter comp, either the control or wear. So in this case, I'm just going to set it to wear. And once again, what wear means is when I set the tool up at the machine, I'm not typing in the tool nose radius. Okay, the tool nose radius is being generated by Mastercam. And then when I control it at the machine, it's just like on the mill with tools. We just compensate however much we need to go, minus a thou, plus a thou, whatever it may be. Where control, we would type in the 32, if you got a 30-second tool nose radius, you type in a 30-second for the tool nose radius, and then you would adjust that number from there. So that's the difference between those two. Okay. All right, lead in, lead out. The last thing I'm going to do here is I'm going to tell it, hey, come in at that angle, and then also extend through the back end of the part. 50 thou, we're going to extend it. I'm going to check mark that, and I can check mark here now, and there is my finished toolpath. Okay, so if we go watch this in Verify, okay, there we drilled, there it's roughing, and there was the finish. Okay, and then I can turn on my half views here so you can kind of see the profile of that part. Alright, so that is basically a boring operation. You know, it's pretty simple. Basically, instead of turning the OD, you're turning the ID. Main thing is making sure you get the correct tools and you know, apply the proper principles as far as entry and exit motions go. Once we got all this done, we could always go in and click on all of it, and then we can post out our code. So we could post that right here and just take a look at it. And there is our turning code. Okay. All right. I hope everybody was able to follow along. If not, rewind the video and do it again. Get this drawing and program all ready to go, and once you have it completed, you can submit it. Have a great day.